Hi, welcome back to my YouTube channel. If you don't already know, my name is Animal Abdul Wahab and I'm a college math instructor. In today's video, we're going to look at how to differentiate some more functions. I think by now there are two videos on the channel in this particular playlist that speak about or that we have solved problems on differentiation. And if you have not watched those videos, you should go back to those videos, watch them first, and then come back to this video. And of course, if you have not subscribed to this channel, now is the right time to do that. Like seriously, subscribe to the channel. The channel is very cool. You guys are already vibing with me, and I'm enjoying, making videos for you guys to explain these concepts. Now, let's get right into this particular video. Now, the first thing that you have to take a look at, you can just scan through the problems to see the nature of the problems. So if you notice this problem, this problems that we have in front of us is a combination of, mostly this will be testing chain rule, right? A little bit of mostly chain rule, because I feel like most of my students and most of the students out there have problem on identifying when we should use chain rule and how we should use it. So these problems would help you to get more skilled at using chain rule. So let's get down to business. So the first problem. So we are to find the differentiation of this. We have to differentiate this function, right? Now, what I always tell you guys on this channel is, once you want to differentiate a function, the best way to see what you need to do or how the things that you have are related is to simplify the function by using other variables as substitution for them. So you can see that what we have ln of this function. So it makes it easier if I can substitute another variable for this function, u. So I'll just say, okay, let u be 3 minus 4 cos x. Now this would simplify my function to be ln u. Okay, right. Remember what I'm looking for is what? dy dx. Okay, now if you notice, in order to get to x, now I need to pass through u, right? So instead of going dy dx, I go through u. So this is how you know you have to use what? Chain rule. Okay, now we need to find dy du and we need to find du dx. I think dy du is very easy. Dy du, which is differentiation of this function, that will just be 1 over u. That's the differentiation of ln function. Okay, what about du dx? Du dx is about differentiation of this function. Okay, now if you differentiate this with respect to x, the first one will be 0 because it's constant. The second one will just be minus 4 multiplied by the derivative of cosine, which is what? Minus sine x. Okay, so that gives you 4 sine x. Now you are ready to solve the problem. So the problem, the solution is dy du, which is 1 over u, multiplied by what? Du dx, which is 4 sine x. So you have to substitute your u back over u. So this gives us what? 4 sine x all over u. What is u? Don't forget your u, 3 minus 4 cos x. So this is the solution to this problem. By breaking it down one by one, this is how you should solve this problem. Now let's move to B part. So B, so let's solve B here. B says we should find derivative of y equal to ln cos 3x. Again, you can see that you have nested functions, right? Ln, cosine, and then 3x. So you have, this is the external one, this is the middle, and this is the internal, right? And we already said you can do this in one stroke, which means you find the derivative of the external times the derivative of the middle one times the derivative of the internal. But let's say we want to break this thing down bit by bit, like we did the A part. All you need to do is substitute a variable for the internal, the whole of the internal, the middle and the internal, everything. Substitute another variable for it. So let's say the variable is u. So which means let u be cosine 3x. Then which means y is going to be ln u. Okay. Again, we have to find the y dx, which is the y du using chain rule multiplied by what? Du dx. Now, the y du, we already know is 1 over u, like the y du is equal to 1 over u. Now, what about du dx? We know we have to use chain rule here again because we have two nested functions, again, cosine and the one of the inside, 3x. So we know that what we need to do is to find the derivative of the external one multiplied by the derivative of the internal one. Now, derivative of cosine is minus sine of whatever is inside that function, multiplied by derivative of 3x, which is just 3. So you have minus 3 sine 3x here. So we can bring things together, 1 over u. So dy du times du dx. So 1 over u times minus 3 sine 3x. So this gives us minus 3 sine 3x all over u. What is u? U is just cos 3x. And this gives us minus 3 tan 3x. If you know the trig substitution, sine of any function over cosine of that same function will give us tan of that function. Okay, so this is the solution to the second problem. Now let's look at the third one. So what's the third one? The third one is cos raised to power 3. So y is what? Cosine raised to power 3 times 3x. Cosine of 3x raised to power 3. Okay. All right. So notice that this is the same thing as cosine 3x all raised to power 3. So when you see this, you know that well, you have convolution of two functions again. In fact, you have three functions. You have cosine, you have 3x, and you have this cube. Now, which one is the external? The external is the last one, which is raised to power 3. Now, this will be the middle one, and this will be the internal. Okay, so what would we do? We will substitute value for the internal function. So all of it. So let u be cos 3x. Okay, then that would make y to be what? U raised to power 3. So remember again, we need to find the y dx, which is the y du times du dx. Okay, now what is the y du? So the y du is derivative of this with respect to u, which is just 3u squared. And then what is du dx? Du dx is just derivative of that with respect to x, which is just, again, is chain rule. Derivative of cosine is going to be minus sine times whatever is minus sine of whatever the function inside the cosine is, which is minus sine 3x, multiplied by derivative of 3x, which is just 3. So again, we have minus 3 sine 3x. Okay. Now, putting them together, dy du is just what? 3u squared multiplied by du dx, which is minus 3 sine 3x. Okay, so which will give us minus 9 u squared sine 3x. Remember, we have to write everything in terms of x. So what is u? U is what? Cos 3x squared sine 3x. So this gives you the answer to the problem. Okay, so that is for C. And finally, let's solve the D part. Now, the D part is meant to challenge you, right? So let's look at the D part from here. So let's write the function out. So we have y as ln of 3 tan 5x raised to power 3 plus e raised to power cosine 5x squared. E raised to power cos 5x squared. Okay, so let's break this problem down. Okay, now when I see this problem, what do I see? The first thing I see is what? I have addition of two functions. I have this plus this. So for me to find the y dx, this is basically saying find the derivative of this, of everything, right? Where y is the same function. Okay, let's quickly write this. And I know that what derivative of sum of functions is same thing as what? Sum of their derivatives. So I can separate them into finding the derivative of the first function. So I know that what addition rule is what is guiding this, plus the derivative of the second one. So that means I need to find the derivative of each of these functions and then add them together in the end. So my question becomes, what is the derivative of this and what is the derivative of this? Okay, now if I can find the derivative of those two functions, I can just add them together to get my final answer. So let's break this thing down separately. Let's say, all right, so let's write this. So we understand that what now we can just use dummy variable here. Okay, we can just look at it as if we want to differentiate this function. This is actually, so look at it as if this is the problem you are given, right? We can actually do this in one step. I can do it in one step, but I need to break this thing down for you guys. So let's say this is the function that you need to what differentiate. Once we get the answer to this, we just substitute back here. Now, what is the derivative of ln of 3 tan 5x cubed? Okay. Now, again, you can see that this is going to be chain rule because we can substitute a variable for the inside of this ln function. So we say let u be 3 tan 5x cubed, which means our y will become ln u, right? So dy dx would be dy du times du dx. Now dy du is already known as 1 over u times du dx. So we need to find the derivative of this du dx. So what is that? 3 is a constant, so we can take it out. Now you can see you need to find the derivative times derivative of what? Tan of 5x raised to power 3. Now notice that this is going to be chain rule again because you have tan and you have 5x cubed. So you will have to multiply the derivative of the external function multiplied by the derivative of the inside of the internal function. So this will give us, so it's going to be, you can see there's a chain rule inside another chain rule, okay? So we don't want to prolong the solution of this problem. So let's just do it at once. So we can take the 3 out because when you have a constant multiplying a function and you want to find the derivative of that function, you need to take the constant out. It doesn't affect the solution. So this becomes 3 times the derivative of, so I could just say this is 3 times the derivative of tan 5x cubed. This happens to be derivative of tan 5x cubed happens to be a function we have to use chain rule to solve. So the derivative of tan of any function, tan as a function is what? Secant square of that function. So it will be secant square of whatever is inside the tan, which is 5x cubed. Now we need to multiply this with what? Derivative of the inside, which is derivative of what? 5x cubed, which becomes 15x squared. So to simplify this, this is 45x squared, secant square of what? 5x cubed. Now this is derivative of du dx. So we need to multiply that here. So dy dx will be dy du, which is 1 over u. Remember, derivative of y with respect to u is 1 over u, because we have ln function, multiplied by du dx, which is just 45x squared secant square 5x cubed. Now let's put things together. This gives us 45x squared secant square 5x cubed all over u, right? And what is u? 3 tan 5x cubed. Okay, so we can 3 can go into 45 to be 15, so that will give us 15x squared secant square 5x cubed all over tan 5x cubed. Now, you can actually simplify secant square of this over tan of 5x cubed, but you don't have to. Let's just leave it as it is for the meantime. So for now, we have been able to find the derivative of this function, which is this 15x squared secant square 5x cubed over tan 5x cubed. Now let's move to the second function. We need to find also the derivative of e raised to power cosine 5x squared. So let's take it as another another function that we have to find the derivative of e raised to power cosine 5x squared. Okay, Okay. Now, again, this is going to be chain rule. So what we do is we can see this is the external function E. The internal part is this cosine of 5x cubed. So we substitute a variable for the internal part of the function. So which means y will be e raised to power u. So remember we're looking for dy dx, which is dy du, because we are going through u, then d times du dx. Now, what is dy du? So dy du is basically easy. The derivative of y with respect to u is actually the same function, e raised to power u, right? Now, what is hard is derivative of what? U with respect to x. Now, how do we do that? This is derivative of this function. So we're going to do it at one stroke again. Now, this is convolution of two functions again, rather nested. These functions are nested together, which is cosine and 5x squared. It's just one function, but nested together as one. Okay. So what do? We multiply the derivative of the external multiplied by the derivative of the internal again. So that will be derivative of cosine, which is what? Minus sine of whatever is inside the cosine function. Multiply by derivative of the inside, which is what? Derivative of 5x squared, which is what? 10x. So we see we are just using chain rule at once, right? So like I said in the first video, if you haven't watched the video, this is the right time to check that video out. The link will be in the description. The playlist will be in the description. So make sure you watch all the other videos in this particular series. Okay. Right. So we find the derivative of the external function multiplied by the derivative of the inside. When we are using chain rule, that's what we do. So the derivative of cosine is minus sine of whatever is inside of whatever the function is that is inside the cosine. Multiplied by derivative of the inside now, which is derivative of 5x squared, which is 10x. So now we can write this thing out. Okay, so that is the u dx. So we can bring everything together now. Dy dx, the original problem, which is using chain rule, dy du, which is e raised to power u, multiplied by du dx, which is minus 10x sine 5x squared. So when we write everything together, we have e cosine 5x squared. We can place the minus 10 here first. Okay, so minus 10x e raised to power cos 5x squared multiplied by what? Sine 5x squared. So this is what we have for the second function. So now what is left is we bring them together into the original problem. So let's just write them here. So what we have is derivative of the first one. Remember, with the initial function we wanted to differentiate as y equal to this lane function plus x, this exponential function. So derivative of this lane function, we got it, which was 15x squared secant square of 5x cubed divided by tan of 5x cubed. Okay, so let me, okay, so this is what we have: 15x squared secant square 5x cubed all over tan of 5x cubed plus the derivative of the second one, which is the one we just finished, is what? Minus 10x cosine of, minus 10x. Okay, just write minus 10x sine 5x square. Then we have e raised to power cosine 5x squared. So we can write it one final time. So you can see that the work could really get tedious, but if you work judiciously with the principles that I've laid out in the video so far, you would be fine, right? It's something that you can manage no matter the complexity. All right, so this is the final answer to the problem. And that brings us to the end of this video. Make sure you check the link down in the description for other videos in this playlist so that you can watch those videos as well. It will help you understand all the techniques for differentiation, and I'll be coming up with more problem set in this particular channel. So try as much as possible to keep following every day for new updates and videos that I'll be uploading on this channel. Try as much as possible as well to share this on your social media channels so that other students like you can see the videos and they'll benefit from it. Click the bell button so that you get any notification. You get a notification anytime I post a new video. So that will be the end of this video. I'll see you guys in the next one.